Okay, good day to all of you. So in this video tutorial, we're going to learn how to convert a decimal number to binary number. So decimal number is a base 10 because it has 10 numbers which is starting from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 9 is the highest number for decimal number. And then we have binary. So it's base 2 because it only composed of two digits, which are two numbers rather, which is 0 and 1. So to convert a number from decimal to binary, of course, we're going to start with a given decimal number. So for example, we have 635.365 and then 1. So we can already omit base 10 because we already have decimal. So, how are we going to solve decimal to binary? So, in comparison with binary to decimal, in which you're going to solve the integer part and the fraction part almost in one computation. For decimal to binary, we have to separate our integer part and our fraction part. So first, we have here our integer part, which is 675, and then we have the fraction part, which is 0.3651. We're going to solve it separately because we're going to apply different operations for these two parts of the decimal number. So let's start with 675. So we have 675. So we have divided by, okay, we're going to divide 675 into what's our divisor. Since we're going to binary, and which is that is base 2, so our divisor here is 2. Okay, so again, for integer part, so the integer part will be divided by the base where we're going to convert it into. So that's why it is divided by 2. So okay, so let's just use here. So we have 675. Okay, let's do it manually. 675 divided by 2. So we have 3. 3 times 2, 6. And then 7. So how many 2's are in 7? So we have 3. 3 times 2, 6. And then we have 1. 7 minus 6 is 1. And then we have 15. 15 divided by 2 is we have 7. 7 times 2 is 14. And then, okay, 15 minus 14 is we have 1. So our answer here is 337 remainder 1. Okay, so let's write it in here. We have 337, okay, remainder 1. We're going to put the remainder here at the right side. And then next is divide it 337 again into by 2. Okay, so we have 337 divided by 2. So we have 1 times 2. Okay, so we have 3 minus 2 is equal to 1. And then 13 divided by 2 is we have 6. 6 times 2 is we have 12. 13 minus 12 is 1. And then bring down 7. So 17 divided by 2 is we have 8. 8 times 2 is we have 16. Okay, so we have remainder 1. So our answer, next answer is we have 168 remainder 1. Okay, if you could notice, as long as it is an odd number, we always have a remainder of 1. Okay, next is we have 168 divided by 2. So 168 divided by 2. Okay, if you can solve it actually mentally is we have 80. Okay, we have 84. Okay, so next is we have 84. So 84, okay, do we have a remainder? Okay, if it is an even number, the remainder will always be 0. And then next is we have 84 divided by 2. So if we can solve it Manually, 84 divided by 2 is what? So we have 42. And then since it's an even number, so its remainder is also 0. And then next is 42 divided by 2 is what? We have 21, remainder 0. Okay. Then next is we have 21 divided by 2 is we have 10, remainder 1. And then 10 divided by 2 is 5, remainder 0 since it's an even number. And then 5 divided by 2 is we have 2, remainder 1 because 5 is an odd number. And then 2 divided by 2 is what? 1. Since 2 is an even number, the remainder is 0. Okay. Are we going to end it here? No. Because our purpose here for the repeated division, it must approach to 0. So next is we have to also divide it by 2. So 1 divided by 2 is we have 0, remainder 1. Okay. If you want to, just demonstrate it. So 1 divided by 2, since 2 is bigger than 1, it's already 0. Then 0 times 2 is 0 and then 1. So that's why our remainder here is 1. Okay, for this one, for integer part, so we already have this values. Okay, so for this value, okay, we're going to read it upwards. The value should be read upwards later for the final answer. So again, for integer parts, repeatedly divide it to the base number where you're going to convert your number for specifically for decimal, and then it must approach the dividend must approach to 0. So let's proceed for our fraction part, which is 0.3651. So for 3651, so allow me to write it in here. So 3651. So for our example here, okay, if for the integer part is we're going to divide it by 2, for this part, for the fraction part, we're going to multiply it by 2. Okay. How many times are we going to multiply? If for example the direction is up to 2 or up to 4 places, we have to repeatedly multiply the result by 2 4 times. Okay. So assuming that since the fraction part here is 4 fractional parts, so let's provide also 4 places. So we have 2 times 1 is 2, and then 2 times 5 is 10. So carry 1, 2 times 6 is 12 plus 1, 13. And then 3 times 2 plus 1 is equal to 7. And then we have 0 here. Okay, since there is no, for example, let's put it here 0. Since this is 0, we have to separate 0 here for our next for multiplication of 2. Do not include the whole number or the integer part here, because if you will include it, the values that will produce will not be 0 or 1. Okay, this actually integer part will be used as the values for the fractional part of the binary number. So we already have 1. So again, let's multiply it again by 2. So next is we have 2 times 2 is 4. So 2 times 0 is 0. 2 times 3 is 6. And then 2 times 7 is 14. So since 1, 2, 3, 4, we have 4 places. 1, 2, 3, 4. Okay, put a point between 1 and 4. And then, as I've said, separate the integer part or the whole number. Okay, so we have 1. As I've said, if you really insist to include this 1 while multiplying for the next, to get the next places, you will have a mistake, for it will not appear as 0 or 1. Sometimes numbers 2, 3, and any other number will appear, which is wrong because binary number is only composed of zeros and ones. Okay, next is we have multiply it by 2 for our third value. So we have 4 times 2 is 8. And then 2 times 0 is 0. 2 times 6 is 12. Carry 1. 2 times 4 is 8 plus 1 is we have 9. And then since we don't have a value here, let's put again 0. And then last one, so 1, 2, 3, another 1 times 2. Okay, so we have 8 times 2 is 16. Okay, 16. Okay, then carry 1. 2 times 0 is 0, then plus 1 is we have 1. 2 times 2 is 4, and then 2 times 9 is we have 18. Okay, since we already again have a 1 here, let's separate it. Okay, so let's just end here because we already have 4 values. So, as you can see, as you can remember for our first integer part, we have to read it upwards, while the fraction part, you have to read it downwards. So, what will be our final answer? Okay, our final answer is we have 1010. Okay, we have 1010. Okay, let's again return 1010, 1010, then 1000, and then 11. Okay, 11.0101 base 2. Okay, so this is our final answer. So to check if our answer is correct, so we can apply the putting weights on the digits, such as we've done with we are doing with binary to decimal. So we're going to put 1, 2, 4, 8, 16, 32, 64, 128, 256, and then 512. And then we have 0 0.5, 0 0.25, 0 0.125, and 0.6, 0.0625. Okay, so let's just, if you want to make sure that your answer is complete, so we have 512 plus 128 plus 32 plus 2 plus 1. All with the ones. So we have 512, 128, 32, 2, and 1. And then we have 0 0.25 and 0 0.0625. So let's add. So we have 5, 2, okay, 5 plus 6 is we have 11, carry 1, okay, 3, and then 2 plus 8 is 10 plus 2, 12 plus 2, 14 plus 2, we have 5, and then carry 1, 1, 2, 3, 4, 5, 6, 7. So 1 plus 1 is 2, plus 2, 4. 4 plus 3 is we have 7. And then 5 plus 1 is 6. So the answer is 675.3125. So let's check. So we have our integer which is correct, which is 675. And while the fraction part is 3651, we get 3125. So the question now is it wrong? Actually, it's not wrong. Why? Because it just means that 3651 is not a power of 2. It's not a sum of powers of 2. So 3125 means this is the nearest value to 3651. So do not be confused or worried that, oh, why is my fraction part not exactly the same with if I've checked the values. It's because again 3651 is not really a sum of powers of 2 of zero point 0.5, of 0.25, 0.125, and 0.0625. So actually you don't have to worry about it, as long as of course you have to make the integer part correct. Actually, if we're going to continue our addition here, since also it's not exact because we're only limited up to 4 decimal places. Actually, in real life, There are others that for example, the goal is make this fraction parts approach to zero. That is possible if the fraction part is a sum of this powers of 2. But since what if the number is not? So that's why there are times that the values are repeating, or it will never approach to zero because it's not really part of the powers of 2. So that's why for the solution, it's either truncated for a number of places, for example, for this one, up to 4 fraction parts. So as not to burden the solving, because if we're really going to, the goal is to approach this to zero and it will never approach to zero, then you can never finish your calculation. So again, for further reinforcement of learning, so I'm going to provide another example. So let's have example 891 point. Okay, so we have 603 7. Okay. So again, let's separate the conversion of the integer and fraction part. So we again, for the integer part, so we have 891 divided by 2. Okay, so we have 891 divided by 2. So we have 4, 8 times 2, 8 divided by 2 is 4, 4 times 2 is we have 8, and then 9 divided by 2 is we have also 4, 4 times 2 is we have 8, and then 9 minus 8 is equals to 1, and then carry down 1. So 11 divided by 2 is we have 5, 5 times 2 is equal to 10, 11 minus 10 is 1. So we have 445, remainder 1. So next, divide this again by 2. So we have 445 divided by 2. So 4 divided by 2 is 2. 2 times 2 is 4. So 4 times 4 is 0. Then carry 4. 4 divided by 2 is 2. 2 times 2 is 4. 4 minus 4 is 0. And then bring down 5. 5 divided by 2 is we have 2. 2 times 2 is 4. 5 minus 4 is we have 1. So we have 222, remainder 1. Okay, next. 222 divided by 2 is what? You can already solve it manually if you want to. So we have 111, remainder 0. And then next is 111 divided by 2. If, okay, we can use this to solve if you're not sure. So 111 divided by 2 is 11 divided by 2 is we have 5. 5 times 2 is equal to 10. 11 minus 10 is equals to 1. Bring down 1. And then we have 11 again divided by 2 is 5. 5 times 2 is 10. 11 minus 10 is equal to 1. So we have 55, remainder 1. Okay. Next is 55 divided by 2. So we have 55 divided by 2. So we have 5 divided by 2 is we have 2. 2 times 2 is 4. 5 minus 4 is 1. Then bring down 5. 15 divided by 2 is we have 7. 7 times 2 is we have 14. And then 15 minus 14 is equal to 1. So we have 27, remainder 1. And then again, 27 divided by 2 is what? We have 13, remainder 1. And then 13 divided by 2 is we have 6, remainder 1. And then 6 divided by 2 is we have 3, remainder 0. And then 3 divided by 2 is we have 1, remainder 1. And then 1 divided by 2 is 0, remainder 1. And then again, so this fraction part will be read upwards. Their values are read upwards. So next is, we have let's solve the fraction part of 0.6037. Okay, so again, another is we have 0.6037. So again, in 4 fraction or fraction parts or places, so times 2. So we have, okay, 14. 7 times 2 is 14. So 4 carry 1. 2 times 3 is 6. Plus 1 is 7. So 2 times 0 is 0. 2 times 6 is we have 12. So 1, 2, 3, 4. 1, 2, 3, 4. So leave 1. Do not include it in your computation. Then next is multiply it again by 2. The 0.2074. So we have 4 times 8 is equal to 4 times 2 rather is equal to 8. And then 2 times 7 is equal to 14. Carry 1. 2 times 0 is 0 plus 1 is we have 1. And then 2 times 2 is equal to 4. And then we have here, we don't have any value, so it's a 0. And then again, times 2. Okay. 0.4148 times 2 is 8 times 2 is we have 16. Carry 1. So 2 times 4 is 8 plus 1. We have 9. 2 times 1 is we have 2. And then 2 times 4 is we have 8. So again, no value again. So it's still a 0. Okay, next is we have times 2. So last 2. So we have 6 times 2 is 12. Okay, carry 1. 2 times 9 is equal to 18 plus 1. We have 19. So 2 times 2 plus 1 is equal to 5. 8 times 2 is equal to 16. Okay. So again, separate it. So since we already have 4 values, so we have 1, 1, 0, 0, 1, and then we're going to read it by the order. So let's have our final answer. So our final answer will be, okay, 1, 1, okay, then 0, and then 4 ones, and then 0, and then 2 ones, 0.1001 base 2 for binary. Okay, again, let's check if this is correct. So again, so we have 1, 2, 4, 8, 16, 32, 64, 128, 256, and 5112. And then for fraction parts, is we have 0.5, 0.25, 0.125, and 0.0625. Okay, so we have, let's add 500, okay, wait, 512 plus 256 plus 64, all the ones, 64 plus 32 plus 16 plus 8 plus 2 plus 1, and then we have 0.5 and 0.0625. Okay, so we have 5, 2, 6, 5, and then we have, okay, we have 2 plus 6 is we have 8, plus 4 is 12, plus 2 is 14, plus 6 is 20, plus 8 is 28, plus 2 is 30, plus 1 is we have 31, 1 carry 3, 1, 2, 3, 4, 3 plus 1 is 4, plus 5 is 9, 9 plus 6 is 15, 15 plus 3 is 18, 18 plus 1 is 19, and then 1 plus 5 is 6, plus 2 is we have 8. We have 891.5625. So again, let's check. Okay, the integer part is correct. But of course, for fraction part, since we are only limited with 4 fractional parts or places, so 0.5625 is the nearest value in 0.0637. And again, it's 0.0637 is not really a perfect sum of those powers of 2 with negative exponent. So this is all about, again, the decimal to binary. So, and also, as you can remember, since binary has only two values, 0 and 1, make sure that your digits here are all collections of zeros and 1. So, I hope that you've learned something with regards to solving decimal to binary number system. And then I hope that you're also ready to learn the other number conversions that is needed. So, thank you very much. Good day and stay safe.